In this video, I would like to tell about the Refined DNet, a weekly supervised refinement framework for single image dehazing. Now we are going to see about the overview of our process. Image dehazing is the process of visually improving the degraded visibility caused by atmospheric conditions. The main objective of single image dehazing is to remove the haze or fog in the image completely without degradation. Some common applications of this technique include video surveillance, underwater imaging, image composting, image editing, interactive photo montage, etc. In our process, we have to detect the haze or to remove the haze from the pre-processed image by using the dark channel prior, that is DCP, and transmission map. We propose a new haze removal technique for a single input hazy image using dark channel prior with the haze imaging model, that is transmission map. Finally, the experimental results shows that some performance metrics such as peak signal to noise ratio, that is PSNR, and mean absolute error, that is MAE. So this is the overview of our process. Now we are going to see about the flow of our process. So this is the flow of our process. First we have to take the data set. So the data set contains the n number of haze images. So just we have to take one input images, then we have to pre-processing the original image. In this step we have to use image resize. Just we have to resize your original image. Then we have to implement grayscale conversion. This means we have to convert the resized image into grayscale. After that we have to implement the haze detection, then haze removal. In these two steps we have to perform DCP, that is dark channel prior and transmission map. With the help of DCP and transmission map, we have to remove the or to detect the haze from the pre-processed image. Then we have to implement the dehaze image. Then finally we have to perform some performance metrics such as MSC and PSNR, and finally we have to predict the result. Means we have to remove the hazes from the original image. So this is the flow of our process. Now we are going to see the demo part. Just I have to run our process. So this is the some input images. Just we have to select one input images from this data set. Just I have to select this, then open. So this is the output. Just I have to explain one by one. So this is the original image. After we have to load your original image, we have to resize your original image. So this is the resized image. Then we have to implement dark channel prior and transmission map so that the result for this is white balanced image. This is the original image, so this is the white balanced image. Just we have to remove some pixels. Then these are the red channel, then green, then blue channel images, gray image. So this is the grayscale conversion for pre-processed image, that is resized image. So this is the initial enhanced image, then final enhanced image when compared with original. So this is the original image with the some hazes, that is the fogs or smokes, fogs or So this is the original images. When compared with original image, so the final result is final enhanced image with remove the haze, that is the some fogs or smoke. So this is the output part. The final experimental some performance metrics like PSNR and MSC value. So this is the output for our process. Thank you.